So last class we have seen about fixed bias common emitter amplifier. So we have started with the analysis of common emitter amplifiers, different bias circuits. We have analyzed the transistor using H parameter model because we are more bothered about the low frequency operation, and we have found the four parameters: input impedance, output impedance, voltage gain, and current gain for fixed bias. Okay, so I have explained it clearly, and I've said that all the further derivations of other biasing circuits are based on fixed bias. So from the given circuit you should be able to draw the AC equivalent circuit. From the AC equivalent circuit you should be able to draw the H parameter equivalent circuit, and then from the H parameter equivalent circuit mark the appropriate current and voltages, apply KVL, KCL, and we can derive the expression for voltage gain, current gain, input impedance, and output impedance. So that is the standard procedure what we followed in the fixed bias circuit. I once again say everything has been explained clearly in the last class. So if you have any doubts, you can download the presentation from your Google Classroom and you can go through. And I have taken all this from the book called Salivahanan. There is a book called Salivahanan, the book which you use for electron devices, right? Same way, Salivahanan has authored a book for electronic circuits also. Maybe I will share that book also in the Google Classroom. That book will entirely cover your syllabus, and additional reading you can do from any standard textbooks which is prescribed in your syllabus. Okay, so that is what I want to convey here, and we are going to continue with the analysis on how to analyze the common emitter amplifier using H parameter model for the second type of bias. The second type of bias is using an emitter resistor. So we have seen that fixed bias is having a very high value of stability factor, and if I want to reduce that, one simple way is I'm going to add an emitter resistance RE here. Okay, I'm going to add an emitter resistance RE. By adding this RE, the stability factor will somewhat be reduced. Okay, so by adding this value of fixed resistance RE at the emitter side, I can reduce the stability factor by some account, thereby making my transistor more stable, and the operating point will also be fixed. Okay, so we are going to analyze this common emitter amplifier, which is going to have a fixed emitter resistance RE. So this is the diagram, it is a common emitter amplifier. So instead of grounding the emitter, RE is connected between emitter and ground. So this is the additional component what we connect. As usual, VCC, RL is the load resistance. Sometimes you call it as the collector resistance, RC. So RL between collector and VCC, and output I take from collector because it's a common emitter amplifier. And input side, I'll be connecting the input or AC voltage, so which is going to have a resistance of RS. So this is the circuit diagram for common emitter amplifier with emitter resistor. If this emitter resistor is not there, this emitter will be directly connected to ground. And what is the purpose of adding this emitter resistance? It is going to add stability to my circuit. It is going to bring down the value of stability factor of my circuit. So as I told in the previous class, stability factor has to be as low as possible. So for a fixed bias, it is very high. It is 1 plus beta, if you remember. And by adding this RE, I am reducing that stability factor by a reasonable amount. So this circuit will perform better when compared to the fixed bias circuit.